Okay, men, welcome to today's lesson. We're going to be talking about the Pythagorean theorem and its converse. We've kind of studied the Pythagorean theorem, but we really haven't gotten into much detail. So today we're going to go into the Pythagorean theorem in great detail. So we know that we have a right triangle. Pythagorean theorem applies to only right triangles. And in this right triangle we see that segment BC is what we call a leg. We see that segment CA is what we call another leg, and segment AB is what we call the hypotenuse. So the Pythagorean theorem states the following. It says that leg squared plus leg squared equals the hypotenuse squared. And I'm going to abbreviate the hypotenuse as HYP. So looking at example number 1, it might be easy for you if you guys would just label the parts of the right triangle as either a leg or a hypotenuse. And a quick tip, remember the right angle box always points towards the hypotenuse. So here, x is going to be the hypotenuse. So it means 7 is a leg, and that means 4 is a leg. So I'll come down here and I will say leg squared plus leg squared equals that hypotenuse squared. So plugging in the numbers, I get 4 squared plus 7 squared equals x squared. We know that 4 squared is 16. We know that 7 squared is 49. That's going to be equal to x squared. If I take and add 49 to 16, we're going to get 65. That is x squared. In order to solve this, we know that we need to take the square root of both sides because a quantity that is being squared, to solve, you take the square root. So here we get that the square root of 65 is equal to x. And I'm okay if you guys leave it as the square root of 65 for right now. Looking at example number 2, again going with the trick, the right angle box always points towards the hypotenuse. So x is the hypotenuse here. We know that 5 is going to be a leg, and 8 is our second leg. It matters not. So all I have to do is write 8 squared plus 5 squared. That will equal x squared. 8 squared is 64. 5 squared is 25. That equals x squared. So I need to combine these. 64 plus 25 is 89. That equals x squared. Again, if I want to solve something that's being squared, I have to take the square root of both sides. So that gives me that the square root of 89 is equal to x. Looking at example number 3, going with my shortcut, 12 will be the hypotenuse, 8 is a leg, and this time x is a leg. So it's just going to add one more step to us solving, but everything is still the same. Leg squared plus leg squared is hypotenuse squared. So 8 squared plus x squared equals 12 squared. So 8 squared we know is 64. I've got x squared. That is equal to 12 squared. 12 squared is 144. So now this is the one step that's different. All we have to do is subtract the 64 from both sides. So I'm going to subtract 64. When I do that, we get that x squared is equal to 80. And now we have to take the square root of both sides, and we get that x is the square root of 80. Okay, don't let the numbers to the right fool you. This is kind of like a multiple choice type problem. And just to show you that we can simplify radicals, just to go and give you one of those in case you encounter one of these on the standardized test. So again, 12 is going to be my hypotenuse. X is a leg. 6 is a leg. So leg squared plus leg squared is hypotenuse squared. X squared plus 6 squared is equal to 12 squared. Here we get x squared. 6 squared is 36, which is equal to 144, because that's what 12 squared is. All right, there's the one additional step. So I got to say subtract that 36 from both sides. We get that x squared is equal to 108. So I take the square root to get x by itself. So I get x is equal to the square root of 108. And in order to figure this out, this is where we have to simplify that square root of 108. So the square root of 108. I know I have to search for perfect square factors that go into 108. So just from my knowledge, I know that the square root of 108 is equal to the square root of 36 times the square root of 3. We could rewrite the square root of 36. That is the square root of 6 squared times the square root of 3. And recall that the square root undoes that which is being squared. So for our final answer, we get that x, the square root of 108, is really 6 square roots of 3. So look up here and I would circle 6 square roots of 3 as my final answer. Moving on to page 2 of the notes, we're going to talk about these things that are called Pythagorean triples. And it is a set of non-zero whole numbers that satisfy the Pythagorean theorem. I won't get into too much detail, but there were a group of people known as the Pythagoreans, and they dedicated their whole lives to finding these Pythagorean triples. Some of the simplest ones you will see up here at the top. So we got the 3, 4, 5, which means 3 squared plus 4 squared equals 5 squared. If I look down on the second line, these are all multiples of 3, 4, 5. So if I take the number 3 and times it by 2, 4 times it by 2, and 5 times it by 2, I get another set of integers that are Pythagorean triples. And if I take 3, 4, 5 and multiply it by 3, I get 9, 12, and 15. You could find all Pythagorean triples of 3, 4, 5, just multiplying them by any other whole number, and you'll get another set of Pythagorean triples. Some of the other most common ones are 5, 12, 13, 8, 15, and 17, and 7, 24, and 25. So if you were to look down here, where you got an example, you may see these on the standardized tests. They love to sneak these in there on us. If you don't know, you could still use the Pythagorean theorem to solve, but they just want you to kind of look and check and see if you could know Pythagorean triples. So looking at example number 5, it says use the Pythagorean triple to find x, explain your reasoning. So if I look up here in the top, I'll notice that 5, 12, 13, if I take and multiply that by 2, I get 10, 24, and 26. So I know that x squared plus 24 squared will equal 26 squared. And without looking, I could look up here at the top and see that missing number, that x will equal 10 by using the Pythagorean triple. And then looking at example number 6, I could also see, hey, if I look at the 5, 12, 13, that's just 5, 12, and 13 being multiplied by the number 3, the whole number 3. So I don't have to write it out like I did last time. I just know that x will equal, in this problem, 15. And you could check yourself using the Pythagorean theorem. Now we're going to look at example 7, where we're going to get into our first word problem. They like these a lot in the textbooks, especially standardized tests. So I know that's something that I repeated myself a lot, but this is really standard for those standardized tests. So if I was to look, it says a 20-foot ladder is placed against the building to reach a window that is 16 foot above the ground. How many feet away from the building is the bottom of the ladder? So I know that x squared is a leg. I know that 16 represents my second leg. That is going to equal 20 squared, which is a hypotenuse. X squared plus 16 times 16 is 256, which is equal to 20 squared, 400. If we were to subtract the 256 from both sides, we're going to get that x squared is equal to 144. If I was to take the square root of both sides, I'm going to get that x is equal to the square root of 144, which is equal to 12. All right, example number 8, again, another word problem. So this time I want you guys to take a moment when I get done reading to try it on your own, and then we'll see if you get the same answer. So it says a 10-foot ladder is placed against a building. The base of the ladder is 6 feet from the building. How high does the ladder reach on the building? So to set this problem up, we know that my ladder is 10 foot long, so we're going to plug in 10 foot right there. It says the base of the ladder is 6 feet from the building, so that represents this bottom box, so that is going to be 6, and then x is going to be how high does it go along the wall. So I'm going to give you guys some time and to go on and check your answer here. Please press pause at this time. Hopefully you guys pressed pause and saw the answer. So after checking your work, you should get that x is equal to 8. So the ladder would reach 8 foot above the wall. That's the end of 8.2 notes part 1. I'll create a second video for 8.2 notes part 2. So make sure you guys watch that second video. See you soon.